Hi guys, this is day 8 of the A2 Economics Revision Challenge, and today we're doing investment in the two-sector model. In our last video, we talked about consumption in the two-sector model, and we looked at how consumption was equal to A plus BY. Today what we'll do is that once we've established consumption, we will now bring what we call investment in the two-sector model. So we will finish our two-sector model, which is basically C plus I, and we look at investment in detail. What is investment? Well, we say investment is simply expenditure on capital goods by firms to produce more goods and services in the future. So the expenditure of investment is done by firms and not by households, and the reason why the firms are doing this expenditure is primarily because they want to produce more goods and services in the future. So this is where expenditure of capital goods is useful, because it helps us or allow us to make more goods and services in the future. In our model, investment is autonomous, which means it is not dependent on income. So if our income goes up or down, our investment amount does not change. So if you look at this diagram, I have investment on my y-axis and I have income on my x-axis, and as you can see is that as income go up, we assume, according to the Keynesian model, investment as autonomous, which means not dependent on income or not a function of y or income. In our previous example, we had consumption is equal to 100 plus 0.8y. Now, what we'll do is this, that we will now add I to be equal to 250, which means since it is a constant, it is not a function of y. In fact, if you remember from our older discussion, that in our consumption we had autonomous consumption as well as induced consumption. Autonomous, why? Because this component is not a function of y. So irrespective of whatever our income was, this part of our consumption did not change. And similarly here also, irrespective of whatever our income is, our investment is equal to 250. So if I go back to this diagram, I'm saying this, that I is equal to 250. So if despite whatever the change in income in a time period, investment amount does not change. And in fact, if there's a change in investment amount, the change will look like this. The whole function may shift upward, for example, from I0 to I1, let's say, when the investment goes up by, let's say, 100, so let's say I1 might be 350, where change in I is equal to 100. So what we say basically is this, that investment is autonomous and it's not dependent on y. Now, how will this change my equation if I have I is equal to 250? We say this, that AE now becomes C plus I, which is equal to 100 plus 0.8y, which is the C component, plus 250, which is my investment. So my AE becomes 350 plus 0.8y. So this becomes my aggregate expenditure function. Now I'll use this equation of AE is equal to 350 plus 0.85 to find out my equilibrium income. If you remember from the discussion of equilibrium income, we said this, there are two conditions that need to be true for equilibrium income. Number one, y must equal to AE, and number two, W must equal to J. So we're going to use these two equations of y equals to AE and W equals to J, and we'll use this to find out our equilibrium level of income. So for the equilibrium level of income, we know this, that first we need to draw our y equals to AE line, which is the 45-degree line. So I'm going to make a 45-degree here, which is the 45-degree income line. And prior to investment, we had only AE is equal to sort of C, and that equation was equal to 100 plus 0.8y. And we also remember from our older sort of discussion in the previous video, our equilibrium level of income was happening at 500. Now our AE function has changed, because now previously if it was AE was 100 plus 0.85, which was simply C, now my new AE is equal to C plus I, or 350 plus 0.8y. So go back to this equation. Let me go back to this equation. Remember, we came up with this idea that AE is now C plus I, which is equal to 100 plus 0.8y plus 250, which means 350 plus 0.8y. So I'm looking at now AE to be 350 plus 0.8y. So now my new equilibrium will happen somewhere here. I'm going to sort of bring a different color. AE is equal to C plus I. So previously if it was 500, now we need to find out this new level of income. So in order to find this new level of income, I noticed that at this point, let's call this point to be A, but this point to be B. At this point B, y is equal to AE. So if I equate y equals to AE, I have two equations. Number one, y is equal to AE, which is the yellow line. Let's call it equation number 1, and equation number 2 is that AE is equal to 350 plus 0.8y, which is my blue line here, and they meet at this point B. So when they meet, y equals to AE becomes equal to A is equal to 350 plus 0.8y. So if I want to find my equilibrium level of income, all I need to do is that put my AE is equal to y in this equation. So I will replace my AE with y, which is equal to now 350 plus 0.8y, which means 0.8 will go on the other side, or 0.2y is equal to 350, or y is equal to 350 over 0.2, which is equal to 1750. So my new equilibrium level of income is 1750. Now this same answer can come through the withdrawal and injection approach. Now remember, I said this, that when you are in equilibrium, y must equal to A, which we just saw, and we got 1750 out of it, but W must also equal to J, which means all the withdrawals must equal to injection, and we call that withdrawals and injection approach. So when we look at withdrawals and injection approach, now we were looking at W, which is equal to only saving. That's the only withdrawal that's happening in the two-sector model, and the injection right now that is happening into the economy is investment. In reality, when you look at the whole model, W is equal to S plus T plus M, and J will be equal to I plus G plus X, and we mentioned that in our older video, but right now, because this is two-sector model, so we only have S and only have I as our withdrawal and injection. So what I'm going to do is basically now make equations for my withdrawal and injection. So we know the withdrawal equation from our older video is equal to saving, which is equal to minus 100 plus 0.2y. Remember this is basically your minus A. Remember, our saving was minus A plus 1 minus B y. So this is minus 100, which is minus A, plus 1 minus B, which is 0.2y. At the same time, your injections J is equal to right now we have in our model 250. So I'm going to put injection and withdrawal in our diagram and find out what my equilibrium level of income will be. So if you look at a diagram would look like this, where W and J will be on my y-axis, and right now my only withdrawal is saving, and my only injection is investment, and income is on my x-axis. We did draw a saving function last time, and our saving function looked like this, where saving was equal to your only withdrawal, which is basically minus 100 plus 0.2y, and that's my only withdrawal happening. And this point here was 500, where we were breaking even. Before 500 we were borrowing, after 500 we are saving. Now what I'm going to do is build upon this my investment function, and my investment function is equal to 250. So when I draw my investment function of 250, what we will find out is this I is equal to 250. This point of I is equal to 250. It meets my saving function. So my I is my only injection, let me write this, I is equal to j, which is equal to 250. So the point where saving meets investment or injection meets withdrawal, this point we'll find out is also equal to 750. How? Let's see this. So I'm saying what w is equal to j, where w is minus 100 plus 0.2y is equal to j, which is equal to 250, or 0.2y is equal to 350. If I take 100 on the side of y is equal to 350 over 0.2, which is equal to 1750. So our answer that we get here, income of 1750, where injections is equal to saving is equal to investments, or injection is equal to withdrawal, is exactly equal to our diagram here, where, or our value here, which is equal to 1750, where y equals a. We can show both of these in the same diagram as well, because we've gotten a result where y was equal to 500 before, and then when we introduced investment it became 1750. So I'm going to show this both in the kind of like a same diagram, something like this. If you look at this diagram closely, what is happening is this, that initially we were at AE naught, where AE was equal to 100 plus 0.8y. Then what happened was this, that we made investment to go up by 350. So this is a rise in I. So there is a change in I here, change in I, which is equal to 250. And then we saw how our GDP, or national income, went to 1750 at a new equilibrium, where AE is equal to C plus I, or saving and investment were equal, or W is equal to J at this point. So what we saw was this: when the investment went up by 250, our GDP went up by, let me write this, change in Y is equal to 1750 minus 500, or 1250. Now what we want to know is basically, why did this happen, that when we increase our investment by 250, our GDP went up by much more than 250. In fact, it went up by 250 times 5, which is equal to 1250. And this is basically what we call our multiplier effect, where we'll see that the change in GDP is more than the change in our aggregate expenditure. So change in AE leads to a more than proportionate change in GDP. And we saw this, that there is a change in expenditure of 350 minus 100, which is 250, but that led to a more than proportional increase in GDP, which is equal to 750 minus 500, or 1250. So why does it happen? I'm going to talk about this in a little while, but I just wanted to first talk about the formulas. The formula for multiplier, we say this, that change in AE times the multiplier is my change in Y, where basically I can rewrite this and I can say this multiplier simply change in Y over change in AE. And in our case, for example, if I take the values, change in Y was basically 1250, and change in AE is equal to 250, because AE was previously 100 plus 0.8y and now became 350 plus 0.8y, which means a jump of 250, and I got myself a value of 1250 over 250, which is 5. Now the way we get this value of 5 is basically, we say this, the multiplier is equal to simply 1 over 1 minus MPC. In other words, in this case, we know this, that our MPC plus MPS is equal to 1, which means my 1 minus MPC would be equal to MPS, because MPS is equal to, if I bring MPC on the other side, 1 minus MPC, which is going to be, in this case, equal to 0.2, because my MPC is 0.8 and my MPS is 0.2. So 1 minus MPC would be 1 minus 0.8, which is equal to 1 over 0.2. And if we do 1 over 0.2, we will get our multiplier value, our multiplier value to be equal to 5. So my value of 5 is simply coming from the formula, which is 1 minus 1 over 1 minus MPC. Now I want to explain why this formula is giving us this value of 5, and why is my multiplier 1 minus 1 over 1 minus MPC. So let's talk about that. To explain this, we'll go back to our circular flow of income. So what happened initially was this, that the firms were giving household an income of, let's say, 100. Right now, if this income of 100 is given to the households basically use this income to buy uh, goods and services from the firm. So there is a consumption that takes place. But before I talk about how much consumption that takes place, we know this, our MPC is basically 0.8 and our MPS is 0.2. So if MPS is 0.2, so this means that whenever you get an income of 100, you don't spend all the income. In fact, you save 0.2 of 100, which is equal to 20. So in our first round, what we say is this, that in a circular flow of income, when let's say a firm is giving household an income of 100 for all the factors of production that was given to it, the household does not consume everything. They save part of it, let's say uh, 0.2 times 100, which means 20 of it, and then they end up spending 80 of it, which means the household has withdrawn 20 but given back to the economy 80. Now this 80 that comes into sort of firm in terms of sort of uh, expenditure is then later again given to households in terms of income of 80, of which households will save now uh, 80 times zero point 0.2, or basically 16 of the $80, because 20% or 0.2 of 80 is 16, which means now the consumption will now be 80 minus 16, because now basically 80 of the 80, 16 is withdrawn away, so consumption will now be 64. What I'm trying to show you guys is this, that one single 100 is now going to circulate in the economy, where every round 0.2 will be taken away. This cycle just does not stop right now. Next time around, what will happen will be, for example, let me just show you. Next time around, now 64 is given in terms of, for example, income. So I'm going to write y is equal to 64, which is going to be the income. Y is equal to 64 is the income, of which 64 times 0.2, which is equal to 12.8, is going to be saved or withdrawn away, and that means 64 minus 12.8 is 51.2 will now be consumed. And this goes on and on and on. So if I add 100 plus, for example, 80 plus 64 plus 51.2 plus all that other incomes of that will follow till it goes to 0, you will find your single 100 income will lead to your GDP or change in Y to be equal to 100 times multiplier, which is 5, or 500. Why? Because we said this, that change in AE times my multiplier is equal to change in Y. So if the change in AE was 100, which is exactly what it is, and my multiplier is 5, I will have a change in Y of 500. And why is my multiplier 5? And we said that is a function of your MPS, how much you save. Now I'll give you a scenario. What if my MPS is not 0.2? What if my MPS turn out to be 1, which means my MPC is equal to 0. Remember, because MPC plus MPS is equal to 1. MPS of 1 means once you give 100 to the household, the household end up saving all of that 100. Isn't that true? Which would mean next round consumption won't happen. So one single 100 leads to one single withdrawal of 100, and therefore no uh, no circular flow will happen. So what will that do basically? That means that my multiplier value will be 1 over 1 over 1 minus MPC, or 1 over MPS, which is 1 over 1. My multiplier will be 1, which means change in AE times 1 will be equal to change in Y. So how much will be my change in Y? And the answer will be one single income of 100 led to one single expenditure of 100. So there will be no change in GDP more than the change in expenditures. What I'm trying to point out is just that MPS and MPC has a role to play. The larger the value of MPS, the more we are withdrawing from the economy, which means the smaller will be our multiplier. For example, if I take a multiplier value, if I don't take these values, what if I take a value of MPS to be 0 and MPC therefore to be equal to 1? When MPS is 0, then multiplier will become 1 over 0, which is equal to 1 over 0, which is equal to infinity, which would mean the economy is not withdrawing anything. If 100 goes from firm to household, 100 will come back, and this process keeps on going on and on and on and on and on, and we will have a GDP that will grow infinitely. So here in this case, what we say is this, that if the MPS is 0, nothing is being withdrawn, and therefore multiplier will be as high as infinity. But if the MPS is very large, which is almost equal to 1 or 1, then your multiplier will be 1, and therefore GDP will not grow at all. Which means the larger, let me write the conclusion, the larger the value of MPS, the smaller will be the multiplier. Multiplier will be very small when your MPS is very high, which because we are probably going to be saving a lot of money and not giving back to the economy in terms of expenditure. And that makes sense basically. Remember, we said that poor countries have very high MPC and very low MPS, and the rich countries, so we know this MPC of the rich country is low, which means MPS is high for the rich countries, which would mean their multiplier will be small. Our next discussion is going to be about factors that affect investment. In fact, it's a very popular exam question. What are the factors that affect investment, and how does a rise in investment can affect GDP? So, what are the factors that affect investment? Well, we say first factor is basically what we call interest rates, and here we establish something called the marginal efficiency of capital theory. The marginal efficiency of capital theory basically argues that there is a relationship between the level of interest rates and investment in the economy. It explains this, that the rate of return in any investment is simply by marginal efficiency of capital. And if you're a profit maximizing firm, as long as the marginal efficiency of capital is greater than the interest rate, then we will always invest in a project. So what is interest rate for us? Interest rate is simply R, which is basically our opportunity cost of investing. If I don't invest, for example, I could put these funds in a bank and I can earn interest on this. So if I decide to basically put my money in a project, then I forgo my interest that I can earn. So as long as I am doing better than the interest foregone, I am going to justify that investment. So for example, let's say a project gives you, for example, a return of, let's say, 20%, but interest rate in the market is, for example, 15%. Then this would mean, because I'm doing better than the interest rate or the opportunity cost, I'm getting 5%, which we call sometimes spread. The spread of 5% means I will invest in that project, because I am doing 5% better than what I could have done if this money was lying in a bank. Now, how do we use this knowledge to make our demand for investment? So in order to get the demand for investment, we say this, that at lower interest rates, more capital projects can become financially viable. Why? Because the cost of borrowing is lower. So when the interest rate falls, we say this, there will be more level of investment or higher level of investment, because more projects can become financially viable. And I want to show this through an example. So let's look at 4 projects. Let's say there are 4 projects the firm can invest in, and all of those 4 projects require the same amount of initial investment, which is, let's say, $100. And all of these 4 projects have different rate of return. In fact, the return is 120. So if I put 100 at the end of the year, I get 20% more. So basically, rate of return is 20% for this project, 15% for this project, 10% for the third one, and let's say 5% for the fourth one. Now, if I tell you guys this, that if this is what the 4 projects the firm can invest in, and if the interest rate is like 25%, which project will we invest in? And the answer is that since the interest rate is much more than the rate of return, we will not put any money in any project. So none of the projects will be taken, or none of the projects will be financially viable. Then comes, what if the interest rate goes to, for example, 10%? Well, if the interest rate goes to 10%, then we say this, that the first 3 projects will be financially viable. Why? Because in the first project, I get a return of, if the interest rate is 10%, I get a return of 20 minus 10, or 10%, or my spread is 10%. In the next one, my spread is 5%. In the third one, my spread is 0. 0 means basically economic profit is 0, which means still this project will be financially viable. So we can say this, that when the interest rate goes down to 10%, 3 projects will become financially viable. And if the interest rate goes to from 10% to, let's say, 5%, 5%, for example, then basically all the 4 projects will become financially viable, which means lower the interest rates, higher will be the level of investment, because more projects can become financially viable. And I can show this in terms of a diagram too. If on my x-axis I have level of investment or quantity of investment, so let's draw this x-axis. I have my quantity of investment. On my y-axis, I have my interest rates, and we're saying this, that when the interest rates are going down from, let's say, 20% to, for example, 5%, previously I was only investing 100. Why? Because when your interest rate is like 20%, you will only invest in the first project, because rate of return is equal to the interest rate. While if the interest rate goes to, let's say, 5%, then I'll invest in all the 4 projects. So my total level of investment will be 400. So if I join these 2 points together, I get myself what we call our demand for investment, which is something like this. It's a downward sloping demand for investment, which basically argues this, that interest rate goes down, more projects will become financially viable, and therefore we will invest more, because the opportunity cost of investing is going down. The next sector we want to talk about is basically called the cost of capital goods. Well, if the cost of capital goods go down, then basically we can say this, that there will be an increase in investment at all level of interest rates as it is becoming cheaper to invest. So what basically happens is this, let's say what I've tell you is that, what if suddenly you don't require 100, but you require, let's say, only 80 to invest. So this number becomes, for example, 80 throughout. So if the project investment amount goes down because the cost of capital goods is going down, then the rate of return will not be 20%, but will be much more. For example, in this case, it's going to be 120 minus 80 over 80, which means it is 40 over 80, or which means the rate of return will be, for example, 50%. And so what basically will happen is that for all levels, the rate of return will go up if the investment amount goes down. So if there is a reduction in the cost of capital goods, we say this, that the demand for investment will go up, because for the same interest rate, something like this will happen. For the same interest rates, we will see if previously I was investing, for example, at 20%, I was only investing in for example, one project. Now, when the interest rate goes, when the cost of capital goes down, then for the same 20%, I might be investing much more. So let's say not one project or not $100, but let's say $300. So what we say is that when the cost of capital goes down, then there is a rise in investment, which means the whole curve will shift to the right. While if there's a change in interest rates, it's a movement along the demand for investment curve. But if there's a non-price factor change, like cost of capital goods is going down, this is a non-price factor, which means not related to interest rates. So non-interest rate factor will result in a shift of the demand for investment to the right or to the left, depending on whether the cost of capital goods is going up or down. The third factor we want to talk about is technological change. What if improvement in technology takes place? Well, an improvement in technology basically results in the productivity of capital to go up, which means the return will improve, which in turn will mean more investment will take place as the demand for investment will rise. So if the productivity improves for capital, the same capital will produce you more output, the rate of return will improve, and something similar like this will happen. The demand for investment will shift to the right. So again, technological improvement will basically improve, not the investment amount might be the same, but the return will improve, and therefore rate of return to improve. So the demand for investment will go to the right, as it's a non-price factor. Lastly is expectations, or what we call business confidence. If firms are optimistic about the future in terms of economic conditions, they will basically be demanding more investment. They will be undertaking more projects as they expect higher return in the future, and this will shift the planned investment to the right. So my planned investment curve will shift to the right as the demand for investment is going up from D0 to D1, because we are now going to have more investment at all level of interest rates. And why are we investing more? Basically, firms are more optimistic about future. They have better business expectations, and that higher business expectations mean they are expecting more profits to happen in the future.